Superconductivity, it's a fascinating and challenging field of physics. Scientists and engineers throughout the world have been striving to develop an understanding of this remarkable event for many years.
Well, this Wednesday, the wise guy is live in his lab to try to explain this complex topic. Matt Sellen, good morning to you.
Hi, Matt. Hi, Gay. How's everybody this morning?
We're just fine.
Well, superconductivity is really interesting stuff, and it's particularly interesting because the theory of superconductivity was developed basically here at Illinois, and a Nobel Prize was awarded in 1972 to John Bardeen for that theory and his coworkers, of course. And it's still a very hot place of research, and this topic is going on right here. It's one of the best places in the world. So to sort of motivate all this stuff, what I did last week was I asked the following question. I asked, what happens if you take a conductor, something that conducts electricity, and you make it very cold? Does it make it easier or harder for the electricity to flow through that object? And it was sort of a trick question because the answer is that it depends on the material itself. And so I want to demonstrate that first before I do the superconductor itself, which I'll do in the second shot. So here I have an electrical circuit. Basically, this box over here is like a battery. I have a wire that goes around. It goes through a little piece of silicon right here, then it goes through this little light bulb, a little LED. And so let's see what happens if I make this little piece of silicon down here, just a diode, very, very cold. I want you to just pay attention to how bright that light is right there. If I dunk this piece of silicon into this liquid nitrogen, which we know is very cold, you see that the light bulb, the little LED, gets dimmer, right? So what happens in this case is when I get silicon very, very cold, it makes it harder for electrons to flow through it. It makes it have a higher resistance, and so it makes it a crappier conductor of electricity. And the reason for that is in silicon, all the electrons are kind of stuck a little bit to the atoms. The warmer the thing is, the more they tend to get loose away from the atoms, and the more electrons can flow through the material. That's because silicon is a superconductor, and I'm not going to I'm sorry, not a superconductor, a semiconductor.
Semiconductor.
Exactly. And so I'm not going to talk more about that today. That'll be the topic for another day.
I know I'm going to sound dumb with this question, Matt, but you made it cold with the liquid nitrogen. Does heating it up do the same thing? It does speed things up?
Yes. So if you took that and you made it hotter instead of colder, you would see that the light bulb got brighter.
Is there equivalent of a superheating, like there's a super freezing, like what you would do with liquid nitrogen, or is that just fire? Are we talking the same difference?
You know, at very high or very, very low temperatures, things get different, and so that's what we'll talk about in the next segment, which is the superconductor itself. But here's just an ordinary piece of wire. This is maybe more apt. This is something that people can really think about, because you've all made circuits like this. It's just a little light bulb here. Here's a wire, and when I dunk this wire into the liquid nitrogen, let's see what happens. The light bulb gets a lot brighter, doesn't it?
It does.
It is very bright. And so what this means is that for metals, things that have a lot of electrons that are free to move very easily, which we can sort of understand, what happens when you get them cold is that the resistivity goes down. It's very easy for the electrons to flow when it's cold. It's harder when it's hot. This has to do with the way the atoms move. The atoms jiggle and bump a lot. The hotter something is, the more the atoms jiggle and bump. And the more the atoms are jiggling and bumping, the harder it is for the electrons to flow through the material, and so the resistance goes up. So when you take a metal, like a piece of copper wire, you get it very cold, the atoms in that material wiggle less, it makes it easier for the electrons to flow. That means that it makes it easier for the current to flow through this little circuit, and the light gets brighter. When it warms up again, when I grab this thing in my hand, and I'm trying not to get frostbite here, then the thing warms up, the atoms jiggle more, and so less current flows.
All right.
Okay.
And so what we're going to see in the next segment is when you make something rather cold, some certain materials, you can get rid of the resistivity altogether. And it's very fascinating.
Okay. We look forward to that.
Superconductivity.
Okay, thanks. Matt Sellen reporting live.